learning opportunity. I wanted from my childhood, I was like learning, I want to do something radio frequency related things. Okay, that is what actually drove me into this. And there is another aspect which is utilitarian. I have another presentation called Pyramid of Amateur Radio Communications, in which we have 7 layers of pyramid. Bottommost layer is ionosphere, second comes location, third comes antenna, fourth comes rig, and fifth, the last one is the person who is the operator. We normally are the operator and rest is utility for us. That is why most of our new generation discussions are about whether I am able to communicate or no. I can communicate with my handy, I can communicate with my, I don't require handy also, I can communicate with my mobile phone also. What does it matter, right? But the hobby gives the opportunity to go behind the scenes, isn't it? So it is an immense opportunity for us. That is why I am just presenting this. I thought when Shyam said if there is any topic, we should be presenting. Okay. This is an opportunity. So bear with me for next 45 minutes to 1 hour. I will be explaining certain things, refresher for many and trivial for lot many probably. But it is a good learning once again for me because I will be uncovering my own learning to you and trying to enhance my learning here. First, I just want to say the picture is AI generated. Okay, nothing to related with me. I have some pictures which are real later.
Sir, I have a point. One point what you said is very valid. In fact, I was just last week I was in my native and I had taken my radio and was just trying to do it. My nephew came, he was like 10 years old, and he said, what are you trying to do? I said, I am trying to do this, this is the Android, this is what. He said, he asked the same question. Why do you want to take so much of pain? I have mobile phone. He bought the phone, I have mobile phone. Okay. Then I said, okay, that is a different thing and this is a different thing. But then it literally, I couldn't literally convince him saying that, okay, this is something different and this has its own way of doing the things and, it has its own methodologies and different things. But he insisted that this is more easy for me. I just click dial and I am able to dial even the international calls also. He has done that, so he knows that. So today's point, that's where I think that it becomes more critical to make people understand these nitty-gritties than because people have seen more advanced technology than what we are probably trying to do. So
they may not be understanding whatever mobile phone they are using is a basic radio.
Yeah.
It's a SDR, software-defined radio, with everything incorporated. Battery system, transmitter. Only thing is they will not be able to open it and repair it. They have to throw that chip out. So that is the only difference. But only thing is like if you have to design that, if you have to go into the next level of understanding, you have to uncover that layer. So it is like onion layers, right? Onion, you go on peeling it. So you actually get more and more
mobile phone, certain basic things like some place you don't get range, some place you get. So that if they know
Correct.
video, then they will be able to understand that much better.
One other way to tell is because of these only they have come out. The evolution of this is this.
ARPANET is the basic invention of amateur radio. So basic smartphone and after that it has come. But anyway, that is the basic thing. Even my kids don't understand what I am doing. That is another story. But it is always that curious minds will attract. That's my this thing, and I always imagine myself sitting in the corner, listening to somebody who is going to tell me something, and I am going to be both you and myself. Okay, I will play that role so that we all can understand this aspect a bit better. So it is going to be lengthy like this conversation. So let me go back to the basics. It's all about basics. I'm not going to. There is nothing new for me to talk. This is not a discovery. This is just whatever I am reading. I am just or understanding, experiencing and expressing. This is like a dipole. Okay. So this is a dipole image from Wikipedia. Most of the things are taken from Wikipedia. If you see the dipole, how the dipole waves form and how the electromagnetics happen around the dipole, you see that changing signs left and right, that is oscillation signals. Basically, I have some other representation. This is just to begin where I am coming from. So where dipole is a balanced system in the way that it has got both the circuits are connected to the load and both the ends are connected to the load, and then it acts like two wings of a bird. Okay, and you have a pattern going, the lobe going towards this particular path, and you will not have any signals towards the end of it. And also, like, there is this particular image which is V, which is going on higher side on this tips. V is voltage. Voltage is higher normally on the tips and minimum at the center, as well as current is maximum at the center and lowest at the ends of the dipole. Okay, just keep this image when I progress ahead, because we are going to have some variations of this and tell why certain things are more efficient, certain things may not be so efficient. So it may be useful for some of you, I hope, in your application at home as well as at the field. Okay. So this is a basic textbook definition of whatever vertical. Now I am coming to the vertical. Vertical is nothing but one half of that dipole. Okay, one half of the dipole, second half is imaginary, which is ground, which is capacitively coupled. These particular elements are capacitively coupled to the ground. That means you cannot actually bury one rod into the ground and say it is a monopole. It has to have a second connection to the ground radius. That is what it is, and it is 1/4 wavelength height. So 40 meter, vertical you have to make means approximately 10 meters you have to have above the ground. This is the ground mounted vertical, and here the pattern of V and I, current and voltage, that is how actually it is. So current maxima is at the bottom, and voltage maxima is at the top. Okay, so that is basically it is, and when it is perfectly tuned on a perfect ground, we are not talking about some radius. Let us say this ground itself is a copper plate or silver plate, entire thing, earth is silver, that is a perfect conductor, right? Then what we are talking about, field point impedance as 36 ohms. It is a perfect ground condition. So lesser you put the radius, 4 radials are very minimal, like people put, right? There it is most inefficient way. Normally it requires 16 or 32 radials and above. So we will not notice most of these things because we are not measuring that levels. We are just like picking up the phone and talking, right? We want to utilize this somehow work and go. I started my ham radio like that only, without knowing anything. Although I knew about theory, I didn't understood its importance until the time when I started giving more importance to the efficiency because of the contesting, because of certain edge conditions. I will show you that real demo also, how actually it means. It means towards the end. Okay, you will notice the difference between the two. Now, how the polarization forms. These are all basics. If somebody wants to know, the good books are there, but I am trying to express the easiest way, right? How many of you know that electric field is not electron movement? Electron literally moving one part of the antenna to the other part. I didn't know actually. Okay, I will tell you that I almost believed always DC current is electron moving entire circuit and AC moving also like that. That is how actually in my younger days people drew electrons across the circuit and all. Electrons never move. It's called drifting. And there is a movement of energy, the field. And the field is across the conductor only. The moment the current is given here, RF current actually, it is like pushing, like the entire material is one, and you are pushing here, entire energy is getting pushed out. It is nothing like an atom or molecules get passed from here to there. That is what my understanding is. If there is a physicist, please explain that better. But our drawings, earlier drawings in the electron circuits and all, electrons moving around, showing all the charges. It is not electrons, it is a field. Where is the field formation happens? Across the conductor, outside of the conductor. That is why we have something known as velocity factor for any movement. Velocity factor, if you have used coax and all, or even if you are used insulated wire versus the normal wire for antenna material, you will come to know. Insulated wire requires lesser length or higher length based on the velocity factor. Normally it is lesser length than the actual copper conductor. Same way coax has got velocity factor variation based on whether it is foam conductor, foam insulator inside like LMR 400 or RG213, which has got a PVC type of insulator. That will be like, for example, if you are taking from our Hyderabad Techno, they will give a proper specification. What is the velocity factor? They measure it. 86 or 88% or something they will say. That means wavelength, actually the travel for the wave in that particular thing takes lesser time. Okay, wavelength is the same, but it takes lesser time, 84% or something. Okay, that's how actually it is measured. So this is the electric field, and changing electric field. When you change the electric field, this is the basic science, right? We all learned. What happens? The magnetic field lines actually form. It is called right hand thumb rule, right, like this. So electric field is moving like this, and this is the basic thing which we are taught, but we never understood that in practice. Okay, I will tell you how actually to understand that in practice. That is my objective. Now, in space, when these two merge, still it is confined. It is here only. It is very near to the antenna. Both electric field and your H is nothing but magnetic field. Electric field is normally considered for polarization measurements. Like when we say vertically polarized, it is electric field which is vertical. When it is your ARSI is horizontal, it is horizontally polarized. That is why it is like horizontal to the earth. That is the electric field which is horizontal or vertical. Then you actually, when you do this is the magnetic electromagnetic field which actually start radiating out E and H combination. Okay, electric field and magnetic field combined. That is another animation is there which I will show where it combines. So please make sure that you understand this aspect, because this is very important from a perspective of understanding the noise. So many people say, I have noise in my location, why it is so? The noise would be there because of the electronic items, lot of SMPS and all that. But how to mitigate you hearing that noise? Okay, how to maximize your signal and reduce the noise absorption into the antenna? That also will be very critical if you understand this concept. This is very basic. This is the ABC of antennas. Nothing new. Now, I had this question, okay, again. Now, if a tank is there, tank circuit is the LC circuit, which is a basic circuit which oscillates, which produces the same signal, why it does not then radiate? Why? Because this particular, you imagine these two are the, your boundaries. In the tank like this, tank is nothing but LC circuit, which is nothing but represented like this, source, resistance and L and C. When it is at resonance, still has got a radiation power, but it does not radiate. It will radiate if you go near to that and put a radio, you will hear the signal. It has got some radio wave, but it's not coming out. You cannot make this particular thing, device, and say that okay, I will transmit all over the world. My first experiment or my first trivial trial back in my college days was this. making one antenna here, small wire, and saying that this oscillator is giving me some signal. I was wrong, right? So that is what actually I'm just saying. This was my observation, trivial, but it is very important. But on this is called closed circuits. Okay, in the closed circuit, we cannot have anything in the proximity. So you will see in our filters and all, in our radios, there would be some cap, like a copper box or something, mesh around very critical parts to shield that. So that external waves or external signals or even smaller metals cannot distort the signals out here. That would be there. If you open up any radio, you might have seen small boxes which are inside there would be some filters. Okay?
When you say close circuit, complete return path.
Yeah, it is inside, so it is not radiating. So here is open, right? It is open circuit. Open circuit representation is like this, right? So imagine R and R is the same, R plus R loss and R radiation, and then you have L and C. When it resonates, it is the resonance. Okay, here, because they are not contained, waves will propagate out. They will not be boundary. It is like putting the waves inside a box and opening that box. That is the open circuit. Okay, in that, very importantly, there are two R's which are very important from AM radio perspective for us. One is R loss and radiation resistance. Loss resistance versus radiation resistance. That is very important and most people don't understand that. Because people think that I put a vertical, just like in textbook, it will work fine. It will not work fine because radiation loss, that resistance loss resistance of the ground beats the radiation loss. Your radiation resistance, it is not radiation loss, it is radiation resistance, which should be normally 36 ohms or 50 ohms. Will now be, you will be thinking when you are measuring the SWR, you are thinking it is matching perfect. My SWR curve is all flat because it is having lot of loss. Okay, you will not get. If you have to measure any resonance, normally the resonance is having a sharper dip in such tank circuit. The moment it is at resonance, it will be like dipping and going up. Okay, very sharp resonance dip. In vertical or any other antenna, you will not see such dips because of there is some loss normally. That is why you will see either flat, slightly flat curve of resonance, or it is slowly U curve. Okay, that is how actually it is. Now this is another factor where I will not read by this. This is how actually if you have this is a vertical antenna out here, and these are the low formation. That is nothing but E and X waves going away from electromagnetic waves going away from the antenna. This is how actually it looks like. Just keep this figure in your mind. So next figure, I will explain how actually it happens. Here in this picture, right, there is something known as the near field and far field. This is another important aspect people don't understand properly, and they always blame certain things on antenna system. Antenna system, I call it as a system because if I am the antenna and all of you are metallic objects around me, you are also part of this system, antenna system. That means the near field, which is normally half lambda, that is half wave of particular this thing, like that wavelength. Less than that, anything will react. That is called reactive field. Anything, I showed that L and C circuit, it will be part of that L and C circuit. So if somebody is transmitting and you are coming into that, he is transmitting like the 100 watts, you will feel that 100 watts. Probably you may not have observed unless you touched it, but you will feel it, that energy is there. Okay, it is like in school days, I have to do a lot of these things and suddenly get my hands into the main supply, and then only I will realize what it means. There is no there is no voltmeter concept, right? Like I don't know what is current. I know current. What is current means like I know it is a shock, and how shock is. I am wondering. I am survived now, right? So this particular diagram. So there are multiple zones. Very importantly to understand, the innermost core, which is showed in yellow, right? Tint is called reactive. That is where anything on your terrace will interact with your antenna, which is very near. Like 40-meter antenna if you put, and 40-meter requires 20-meter radius. So if there is a pipe, steel pipe around, it will interact. It will be also part of your antenna. That is also the moment it interacts, it re-radiates. What is the re-radiation? It will also transmit or receive. That is the important concept I never understood properly till I actually got into that particular subject a little bit deeper. Why it matters? Why it matters is because when we do certain things, we put an antenna on the railing and think that it is perfect. It works, FT8, RTTY, I am not bothered because it is machine to machine talk. But when you want the efficiency, please pay this some attention because this is not trivial. When you want to be a little bit more serious, to make more bang for the buck which you are paying, this is very important from that aspect. You should be putting this antenna on the clear ground. In our native place, I have a house, I have boundary walls, and then there are neighboring buildings. Okay, and neighboring buildings are 15 feet, 20 feet high. And if I am thinking that only my boundary walls, I have a clear path, and neighboring walls and their buildings will not interact, that is wrong, right? Like because that is not clear. It is either in the reactive zone or fractional zone. What is a fractional zone? Fractional zone is this particular.
Does this TV antennas also contribute to this?
All type of metal. How much it depends, because it is all random. Anything metal need not be. I am saying no, like GI pipe.
Even
rusted power
MS.
poles next to your house, power lines.
even the MS pipe we used to hold the vertical inverted.
Yes, sir. They are all part of the antenna system. That is why sometimes when we put, let us say you tune the antenna on an open ground and go to home and try to put the same thing, FWR will be different. That is the reason why it is happening. So fractional zone is this zone, okay, green zone, round. Fractional zone is a place where reactive energy becomes radiating energy. That means like E and H I showed earlier, if you remember, they are contained normally in the reactive zone only. It's all in the reactive zone. Now it transforms into radiator. Radiating means it goes out. This is where the waves break out. If you see this, this particular bean-shaped formation out here, the waves will break out. Like waves normally goes from north to south. Let us imagine the very simple science of magnet, right? North to south, north to south, north to south. The farther you go from the magnet, the waves, what happens? Bigger and bigger, bigger and bigger, bigger and bigger, and you will see that is breaking up at some point. Okay, that particular thing, lines have to naturally come back, but it breaks up because of that, because it is going out. It is not just, it is pinching off, I can say. The phenomenon is like you will be like circling and suddenly you will be pinching off and going out. Okay, that energy field is going, nothing else is going. Don't imagine that you are throwing some object out, plasma out or something, nothing. It is energy, that is the movement, how it happens. Okay. Now then, there is a far field. We want 2D, D here is nothing but dimension of the antenna. D square divided by lambda, 2D square divided by lambda. If it is 40 meter dipole, it is D square is 20 meter square, 400 into 2, 800 divided by 40. That is 800 divided by 40, 20 meters away, again half wavelength and beyond. It normally it is considered far field. So if you want to consider field strength meter, you should not be coming inside this range. You should be going out here. Field strength meters and all. Okay, so in US they have to measure and certify their stations, individual stations for emission. So you should not be emitting more than particular power in the zone and all. They have to carry field strength meter. They carry in this region, not here.
Fresnel zone once, what is the significance?
Okay, Fresnel zone has got a very much significance. That is where, since the waves form, if you have any obstructions, I have a slide. If you have any obstructions there, what happens is it will not be forming appropriate load. You still have radiating energy, but it is like I am speaking to the wall. I am still able to make a clear speech. That is what radiating energy analogy I am giving. But if I am speaking to the wall, what happens? Nothing. Nobody else is listening. So that is what actually importance of Fresnel zone. Another importance of Fresnel zone is if you are near to the beach, salt water, right? Half wavelength and less than that, right? That is the where actually you will form greater significance. You will that particular wave will be benefiting from the Fresnel zone a lot. Two, for the city people, it is avoiding all this as much as possible. That means if you are having a terrace, best place to put it near the tank, above the tank, water tank, and hopefully the next neighborhood is not coming above you. Okay? That has happened to me, that's why I am explaining. I don't have a transmitting antenna or receiving. So this is the elevation, how it goes. See. So same thing, like how actually it pinches off from that center and goes out.
So the Fresnel zone is also a dead zone, you can't receive anything.
Fresnel zone is where it is like I am the antenna. Next to me, some radius, I get interacted with this particular thing, I change my behavior. SWR is going to change. But beyond that, till your far field, SWR will not change. Still your radiation power will not go away. It will not be picking up the power. It is going to die because of the obstruction. That is the place where Fresnel zone is important.
So we need to ensure obstruction is far away from Fresnel zone.
Yeah, that should not. This will
Fresnel zone, there should not be any obstruction.
Yes.
That's what.
This till this point, there should not be any obstruction nearby.
And
After
but-
that, there would be obstruction. Okay, but that will be for your low formation. That is called terrain analysis. We have a software called terrain analysis software in ARL books. If you see, that is part of the location specifics.
You are talking about the measurement of how far away will the
Including.
No, this is the measurement area.
that will be what
This is the approximation, but these are the formulas. This is not in scale. Okay, I am just showing. I just
But in
made it.
this animation, where will the field come?
Far field. So field starts from this green shade.
After the
It forms here.
Okay.
See, the near field is both green and yellow.
Right.
Near field is both reactive and radiating. Radiating starts here.
Right.
Okay, after this anything is field only.
So anything is far field.
Far field only.
Put like I have got a halfway fed on the terrace, put like inverted V, and I've got a building 5-story, this 2 stories taller, 90 degrees to it. How much will it affect?
No,
Next
if it is, see, this is a particular antenna, right? This is a vertical dipole, for
Okay.
example. This is, let us consider you are put in this direction, you are half-wave dipole.
Okay.
Okay, if the building is here, you will not be hearing anything much from this side, of the right side. Okay, if the building is here, does not matter. Anyway, the radiation is very low. Since it is an inverted V system, so normally it is not dipole. Slight energy is here also, but still, if you have aligned like this and building is here, does not matter that much.
Building is 90 degrees.
So you will not get much signals from here. And it also depends on what you are trying to do. You are trying to bounce your signals from ground above and take it back for enemies near vertical instance. That means like you want to do a regional communication from here to Tumakuru, down here type of a thing, or Bangalore. That works best. For this is I'm talking from a perspective of both DX and NMIS. You understand the difference, right? If you are connecting FT8, you may not have much because machine is talking. You will not make out. Okay, you will say, okay, this guy is responding or no.
This is where the receiving
I am talking
noise-
for humans.
This is noise also will be contributed, no?
This is the top view, right? Yeah, this is the top view. And it is a cross section from the top. Okay. Now, if you make it the vertical like here, that is also like the true.
Oh, so this view front.
This view, yeah, this is true. It will be like this. And also, it is not like one slice going, right? It is like a boom balloon, like this, extending. I am showing the slice to make it.
Stone in the water, how it moves. Just like that. It's
Yeah.
like that.
Correct. So you take a balloon, pinch from the center, how the balloon extends both sides, that's how the radiation happens. Means like simple way, the booms formation. And this is what actually called elevation plot. This is from a perspective of average ground and next to salt water. Now again, there is a question for me also. When I express certain things, it is me also. I am asking this so that next time I will get some more clarity, right? So the thing is like this is elevation. That means like if I am standing like this, I am cutting off slice and showing it on both the sides. I showed the other side, other wave formation that now the lobe, the balloon is cut into half vertically. That is how actually this degree is formed. Okay, 0 to 90. This is the horizon. This is the immediate sky, right? Skyway, if you are having a vertical like this, in the sky, there is no signal. That is why vertical is not good for your local communication normally. The moment you put that, you will not get it. Best is whatever he has put. Naren has put for the inverted V or dipole at a low height. Because low height will have a higher lobe. This is called lobe. A higher lobe means it will be like this, doom. That is only useful for your regional communication. This is more useful for your DX. Yeah. So this is average ground. Perfect ground would be even more better than this. So if you see this is at 85 degree, 5 degree elevation. So what happens, if you are a DX or if you are a contester or if you are on a long range communication, I am not talking from a perspective, I want to talk regularly, reliably to Chennai. More reliability my phone can do, right? But still there is more reliability in HF communication 40 meter with the NVS type of antenna. When I put that, so this particular lobe, if you see this gain, minus 8.13 and here it is plus 3.75. This particular angle. This particular angle is required so that we avoid as much as atmospheric or ionospheric path loss. The more you are having a sky wave towards inclination, more hops it has to do. Okay, and lesser hops will be towards the your horizon, so that less number of hops it has to take. So it is more beneficial out here. If you see the energy, it is 3.87 dBs out here. Okay. So best practices, what not to do first, right? This is the fractional zone. This is the fractional zone. This is your reactive, and this is your far field. So first thing is not to have any antenna work near the power line. That everybody knows, but sometimes we ignore. Very dangerous work because you may be lifting your any pole by vergas or this thing. By ignorance, you may be connecting to the wire and doing something harm to yourself. Don't do it. This is the basic. Then these are the two things which I wanted to tell. Avoid this loading coil bottom unless you ban absolutely required for it. Okay. This is the heavy coil which should be avoided at the bottom. Okay. And then these metal structures, avoid it. Any metal structures nearby, try to go away as much as possible. Ideal situation cannot be achieved for practical limitations, right?
So you bring down the frequency of operation. So for 2 meters, not
2 meters and all, the length are very less. 2 meter, what is line of sight, right? Line of sight, you should be having a clarity in the line of sight. If some building is on the line of
nearby
sight,
objects and all.
yeah. Yes. So the principle is the same, but it gets miniaturized, so you will not feel that difference.
So the feed point, which actually is connected to the coil, is always there in the place where you're seeing it, is not, that's how you use it.
Yeah, I will show you.
Kiran, that way, even the iron bars what we put for the RCC roof also will be part of this.
Yes.
So then we
Sure.
can't avoid that at all in that.
No, I am saying the ideal situation is something different, and then you will have a practical. That's why you should understand why it's happening. See, I am not understanding that from the beginning. That's why I am presenting today. That I know why it was not actually radiating at all, and I got myself discouraged because of lot of things. And once the discouragement comes in your mind, not to show off to others, but your own mind, you will not even try to improvise. So let us try to learn why it is happening first, right? Then your signals, nearby objects and hills and all, which is very next to you. Hills also will not be like, line of sight also is a problem, or HF also is a problem, but there is a plus, I will tell you where. This is the Fresnel zone, and the best practices, antenna near field tier, as many as possible. Raise the loading coils if you absolutely must. I will show that antenna. Last time I brought it, right? It is having a coil location half the wavelength above, or half the antenna above. So,
Another stupid question. So the higher frequencies will be less forgiving because the wavelength is smaller. So
no, it is not forgiving. No, nobody is forgiving. RF is not forgiving. We are assuming that it is forgiving. It is not forgiving. But the distances for 2 meter, when you compare that 2d square by lambda and all, very small. So the area of clearance required around that is very small. If you go near to your VHF antenna and hold not from the back, from the near to the dipole end only, you may hold it and measure your FW, or stand near to that, you will come to know what it is. So, or even you carry one any steel item or copper item near to that dipole, just 1 meter, less than 1 meter away from that, you will see the change in SWR and curves and all, because you are now in the reactive zone. Okay. And another important thing which I normally do, this thing is raising the antenna slightly above the ground level, called elevated ground. Okay. This is most ideal situation when you are not able to put a lot of ground radials and you want a good efficiency. So you have to raise your antenna feed point and start feeding that with the elevated radial system. And I told you earlier that avoid hills, but there is an advantage to the hill. If you are on the hill, tapering side of the hill, and if you are putting vertical antenna or any antenna for that matter, you will have a edge in the tapering side. Okay, that means you will have some boost to that side. If I am on the inclined side, that side I have a benefit, but not the back side. So back side, like here, I will not have. This side I will have. And if I put a antenna just near to the beach, don't put the antenna thinking that you have gone to Bangalore and you will put it in some college. It will not work. Unless the college is situated on the boat itself. Okay, that means like you should be as near to that Fresnel zone. Fresnel zone should be near to the antenna. That means like quarter wave or half wave. Within that range only it will work best. Yeah. Distance from the actual salt or above.
How about the normal lake, for example?
Normal lake, I will have one chart. I will show you that. Normal lake is not a salt water lake. Clear water is not a conductor for RF. So, vertical dipole, what I showed the first picture, if you vertically polarize it, vertically keep it, this is how it looks like, and dipole has got another 2 dB. Now I showed you the dB, how much dB it is. I will actually have one recording to show you how it sounds from average ground to sea water, how the difference happens. Also I will have that later to listen, so that we will understand that better, the context in which, because normally when we talk about dB we will not know 1 dB miss हो गया तो कुछ नहीं होता, but actually 1 dB 2 dB nothing, but to make the difference it is 3 dB normal hearing wise, but still you try to use as much as possible. So this is a vertical dipole. Instead of vertical, normal vertical, same place if you put vertical dipole, it is 6.12 dB gain. That is more radiator metal is there. Both sides are there. One side earlier it was considered as a ground, right? Elevated radial ground. Here it is the radiator is twice. So there it was 3.87. It is here 6.12. Approximately 2 dB more gain. Okay. And this is called this plot is like donut shaped plot, right? If you see, this is a vertical. From the top, if you see, this is how actually it looks like. Towards the sky, there is no signal. From all around the object or the vertical, there are a lot of loops.
Kiran, sorry, why the rabbit ears?
Huh?
Why the rabbit ears?
This one.
Yeah.
This normally forms because this is not a perfect ground. If it is a perfect ground, it will not form. These are called minor lobes. So we try to minimize these minor lobes. This is because normally this is the nearer this element is not perfectly aligned, right? There is more interaction to the ground in the lower side of the dipole than the higher side. All this matters. So if you have a program called, this is a free program called 4NEC2. So very simple, you draw the line. It is like a Tinkercad or any drawing program. You draw the line, put a source, and ask it to simulate. Since I don't have a real place, I do a lot of things in simulation land, like a Disneyland. So this is how actually it is. Got it? And it actually reflects the real situation, because I normally compare post the experiment and the real.
The field is in the middle point.
This one. This is your source that you connect. One important thing is when you are having vertical dipole, we have I will show one photo of that vertical dipole, how it looks like. When you have this type of a dipole, your feedback, the coax should be running as parallel to this, as much as it is perpendicular to this antenna, or inclined. Otherwise, it will also be part of the antenna. Yeah, to some extent you have to, then you have to count out.
And how do you minimize the minor lobes?
Minor lobe, if you take this particular thing above it.
Okay, further.
Further above. That is not possible. The height of this is. You put that in free space. So this is I will leave that so that you can distribute it. Cutting the length and going. So how to cut and all that. This is a measurement. Normally we know as hands how to cut.
Sorry, just to come back to you.
This is a quarter wave.
If I suspend the halfway from a 5 or 6 story building about 10 feet away from the wall and sit at the bottom, then it functions normal vertical.
It will work.
Without it touching the ground.
It will work, I will tell you, it will work, but it will not work like ideal this thing, because you are having building in 10 feet, right? Building is a wall, obstruction.
About 10 12 feet away from the wall.
Yeah, that's what I am saying. Fresnel zone on the right side. See, one side it is open, one side it will see the wall, and like this. This side all the waves go, but this side I will interact with the wall.
So basically it acts as a reflector.
It should ideally act like a reflector if you put a metal sheet.
Buildings also have that iron.
The iron cell building.
it is not like pure,
But mostly concrete.
concrete, no, and it is a soil and all this mix. So it will not. If you have aluminum foil or aluminum sheet or anything like that, it is better. Only thing that because it is in the reactive field, you will have to see how far away it has to go.
Or from OFC came
You
you
have to put again a metal sheet for your neighbor's wall.
And your neighbors will complain because they are taking catch all this.
over our building.
Bearing the cost, they may agree also.
तो over our building पे होगा OFC केबल को Airtel main line. So we'll hang it on that.
I don't know.
There are some lucky people like Engineer etc. who step into two apartment blocks. So if you hang it.
It's like it. That's why
That was
very
very
good. Lucky you. Okay. So this is for theory. I just wanted some calculations out here. Radiation efficiency is normally calculated. Radiation efficiency by the entire R. Why R? When there is L and C in the network, because L and C will get cancelled in resonance. Whether it's half wave, end-fed half wave or something, it is the same concept. Only thing is R will differ. That's why you will bring down the R using using that transformer.
The radial length should be 5% more than the.
No, it does not matter if you are putting on the ground. More denser the ground, it is better if it is on the ground. Denser means more radials are better.
But it should form the capacity.
Yeah, it will do. See, the thing is, when you are a quarter wave radial is normally what we call a quarter wave. But even if it is a smaller, 4 quarter wave radial is much less efficient than 8 less than that radials. And it does not matter whether it is 1 quarter exactly you have cut or not. Because most of the time it is a damp ground where you are putting this laying of this. It is not a conductive ground. It matters when you actually elevate. When you elevate, it becomes a resonant tuned radial. Okay.
What we understand, what I understand, is that the ground plane is always 50 students.
No.
No.
36.
Always.
So always it is an ideal 36. If you are getting 50, that means like the ground is absorbing the rest. Ground resistance is more. That is how actually it is. This particular. Just like dipole is not exact 50 ohms. It is 70 ohms or something like that. Near to that. 70, 75 ohms. Something like that. So here also it is not like that.
Then why is it in inverted V it is 50 ohms?
It is not exactly 50 ohms. Sir. Yeah. All interactions in ideal world it will not be. These are all ideal. Okay. So when we measure, we are measuring on whatever we get, right? Ultimately, we try to do our best in whatever available thing. Whatever I am trying to say is, we don't do dumb things on the dumber things. Already some dumber thing is there around us, right? Which we cannot avoid. But what we should be avoiding when we know that certain things are not under our control. What is in our control, we should be knowing it better. And many hands don't know what they should be doing.
When we look at the antenna, the VNA, so whatever you said nearby object, all that also will get reflected here or no, it will just show?
It will not show. No, it will show what antenna sees. That's it. When you do antenna
No relationship to what it will radiate or
you can put a perfect absorber around your roof. Still it will show the same outside the freshness zone.
VNA is only to get the resonant.
Yeah.
See, especially Kota and all that. So there are the absorbent zone.
So you try to do two things. One is like in the field days. Normally, what is your objective? It's all based on your objective. Your objective is to learn something just for the sake of cutting and wire. That is one objective. Second objective is to make some nearby schools heard, Kota type of a thing field day, or regional stations to be heard. You don't require higher antennas. 10 feet, 20 feet is more than enough.
No, I meant particularly about the trees.
Trees, only the wet trees. Wet trees. Yes. Wet trees are reactive. For example, palm tree and coconut tree, trunk.
And generally in the North America, they have attic antennas.
Yeah, they are all dry wood. So this I have observed myself in one of the things when I actually located the antenna next to the wet coconut tree, just touching that coconut tree. SWR used to go back and forth when transmitting. That's when I came to know.
On an elevated feed point, and the radius coming from the elevation, the radius will also be radiated.
Actually, everything is radiating, but the lobes get cancelled. Elevated radial also has got a lobe, but it is getting absorbed. Okay, here the elevation, the efficiency gains up. That is why in the elevated radial system, slightly the lobes, what I showed that lobe, right, the balloon lobe, will go slightly upper, elevated radial. If the ground is kind of perfect type of a thing, like not like average ground, but above average ground and things like that.
Elevated is how I was over 1 meter high on the ground?
Yeah, it depends, like more than 3 feet is okay. The lower the frequency, higher normally you will have to go, but I have done only till 5-6 feet.
And in this case, can you put the loading coil at the bottom with elevated radius?
No, I don't get it. What is it?
I wanted that 6 meter width. I wanted to make a loading coil for 40 meters. Suppose I mount it at the bottom and put the entire system about 4 feet off
It is the same thing, right? Near to the feed point, you should not have any loading coil. That is the concept. But you know, most of the time we will not be able to avoid. Okay, to put it.
So, see, the vertical antenna is a unbalanced antenna. So, and a dipole is a balanced antenna.
Yeah, from a perspective.
Yeah. So, generally it is said, there is a notion that vertical antennas are very noisy.
That is because you are not able to lift it up like the dipole normally. The vertical antennas are near to the ground, or on your terrace also. It would be like situated somewhere in the boundary of that this thing. So it will be picking up, and also like when I say polarization is vertical, that means your noise objects like your SMPS system or cable TV guy may be having some system, power supply system nearby, and LED light system of the apartment. All those type of things are also nearby. They will be picked up very easily. So because they are very close.
For a city antenna, where all this expected noise, including the spark plug noise, etc. What is ideal? Vertical antenna or a dipole?
Ideal is even better than that is to have a delta loop or something loop. Because we are living in the high this thing, high terrace. Normally, if you put 20 feet above or 25 feet, 4 poles or 3 poles, and make it as a loop, horizontal loop, it's called sky loop. Much quieter than all this. But next best is a dipole. Next is vertical.
Loop is the best.
Loop is the best from that perspective.
Quad.
Yeah, quad is that's why quad is considered. Normally it is heavy and big. That's why people don't consider.
Extreme also.
Extreme is nothing but dipole. Dipole angle. So this is just for the conductivity. So you asked about water and all. Water will come somewhere average or less than that. Salt water is here. This is what actually it is. But normal water is somewhere here. Dielectric constant. That is not so good in conductivity and all. It's not good. So if you are thinking that island, normal Kaveri island, I will go and operate, it is not beneficial unless you are having a quieter location. That is the only thing. Okay. Still beneficial than Bangalore. And this is our sketch long time back. Myself went some 8 years back to one small Kudru island. This is an island basically. This is called Kudru in our South Kannada language. Kudra is a small dvipa. Small island formed due to the river joining the sea, estuary. That near there, a lot of over the period of time, it forms.
Backwater also is fine.
Yeah, this is actually backwater. What you see around. This is the island, small island, 1 to 3 acres. That's it. So if you want to go, one road will be there, which will be open during low tide, closed during high tide.
Kiran, please purchase for testing.
It is a Airbnb space. You can actually go.
Kiran, see, here you said you appear tram walk, put all the radials at the elevated point.
Yeah.
Okay, so what difference does it make if you vary the height of the radials? Let us say you said minimum of 4 feet, you are taking that let us say to 30 feet or 40 feet up. Is there any observable difference which is happening?
40 feet up. Radius.
Okay, you are showing commentary over there.
No, it actually the more I cannot go now like that much. I don't have height.
No, all these are commentary. So
currently is like this is 60 feet up.
Okay.
Okay, 65 feet up.
Yeah.
So see, for example, this is one vertical 80 meter up going here and pulled from here. Okay, it's like inverted L type of a thing. This is 40 meter antenna comes here. This is 160 meter inverted L like this. This is one radial, 2 radial for 40, 1 radial for 80, 1 radial for 160.
No,
All these are
very large wavelength. There are just 20 meters. Okay, wherein the space is height is much more manageable. In that case, what happens based on the?
It will become vertical dipole, not vertical.
No, I don't get. So you want to raise the antenna?
No, he is telling
Along with the radius, then what happens?
it will become vertical dipole.
So I didn't hear you.
No, what I want to say is, along with the whole antenna is lifted up from the ground, along with the radials, because it's a shorter 90 meters of.
So what happens, sir?
Yeah.
So what happens is you will lose something known as ground gain.
Okay.
So if you immediately below the ground, then if you are too lower, absorption is there. If you are at too high, you will not have that immediate ground gain. Okay, it will act like a free space after some time. Okay. Normally 4-5 feet is a good idea, but they say that okay below around 1 lambda by 8 is a calculation. That is 1/8 of lambda. Is a actually.
So Kiran, when you
So
showed that estimate,
Kiran, the coconut tree is above there.
No, this is, I will show you the photo, how it is looking. You will not see that, okay, the antenna is raised near to the coconut, although this is like a slanting coconut tree, right? So it is much farther away, it's like 15-20 feet away from the coconut tree or more.
Who climbed the tree to put that tent?
Somebody will be there. First thing is that field day, you have to do is find a tree climber.
It is very difficult to find. I have a 80 feet tree in my village home. I am not finding a guy to climb that tree to put the antenna.
The tree itself, because that fellow did that, when I wanted to.
I went to this place twice, few years back. Both times I asked the landlord. They will have regular guys who come and cut the coconut.
I am the landlord, man. I am not the whole village.
So have some apps invited to your place and you will find that there is no option.
Buy the Kerala climber.
So this is the
when you have the S-neck diagram up, you said when you put it up, it becomes a vertical dipole. With the question he asked, won't it also become a vertical dipole?
It is not, it is a vertical L. And you imagine that, see, vertical dipole is where you have everything here, like
Right,
this.
vertical.
Okay, one edge is connected like this.
Right.
So vertical dipole is like this, not L.
So when you
the
do
lobes
that,
will interact.
no, when you do that at that height,
No, it will not be.
minor lobes go away.
No, it will not go. Because this particular radiation is still like this.
How?
How means like you have to.
No, I don't remember thinking that.
What was the
Because the
Yeah, this is a normal choke. Okay, normal choke hung from the tree. Some see all these wires. It's not. These are the ground radials also maybe or going. So basically, it is like a diamond we did. We pulled all the wires from the side, which will go up first. It should not be nearby, right? It will interact. So we pulled all these wires around. These wires around.
Those are all
And,
radials.
radiators. And the radials are here, backside. Okay. So
Only one vertical and rest of them are radial.
all are vertical. So this is the tree top. This is the tree top. So you will, in this particular picture, if you see from this side, you will look like it is inclined here like this, right? It is not. It is actually vertical. This tree is inclined.
Previous one?
Huh?
Previous one. See here, the center one, only one is the radiator.
Three are there.
One driven element.
Only one.
No, probably it may not be showing complete. But this is all.
But that's a multi-band.
Multi-band, 3 bands.
What kind of performance you want?
See, this is a picture, right? I pulled. This is the first one, which is going directly up. These are the two others which are going up.
One of the blue
But
is
they are,
going further and going.
yeah.
It's
Color
like
convention
DX
is
commander.
DX commander design is nothing but a fan vertical. Don't, no, there is a, we made it famous very recently, right? These are all in the textbooks. It's called fan vertical. DX commander is a brand of that metal also. We made it after those. So this is, by the way, this is given before DX commander became popular.
So,
we never knew.
multiple radiators.
Right.
So the feed point impedance will vary.
No. Same.
It's like a fan.
Yeah, because at resonance, although there are three elements, each will resonate at different frequencies. Okay.
You are using a QLF for this?
No, not in. I don't have a QLF.
So and that is a
Normal, 1:1. You point the cable also, put it that will also. That is just to avoid RF.
Is it a choke or a column?
It's a common mode choke, yeah. Choke only. This point, it is a choke.
What are the wires used actually?
Also,
2.5.
it looks thick now. Yeah, 1.5 mm or something.
Looks going to be fine.
So this is how actually tossed from the bottom. So if you see, and this is the vertical dipole array. This is a dipole vertically aligned, and backside is the reflector. This is taken from long back on the expedition, Andaman Nicobar. Okay, this is the sea touching this particular fiberglass core.
Two vertical dipoles.
Here different, 10 meter, 15 meter. We had 6 vertical dipoles. So next picture is like this. These are all ideal condition human can achieve, right? Like I can achieve. This is the best I have seen, not anywhere else. So these are the vertical dipoles. These are the parasitic, not phase arrays. Two antennas, vertical antennas, fed with the same phase. That means the lobe will be like this, horizontal, like dipole only. The lobes are rotated at this particular wave, right? This is actually low tide, slightly low tide. Otherwise, there is a high tide when we went there. The water was like near to my waist level. Now it is only 1 feet or 2 feet.
So this also is slightly directional. This
This is all. That's what I told you. This is directional. Yeah.
Only in the
Yeah. So to get the same gain on dipole, we will have to go probably 30 meters high. That much difference. 30 meters.
Which configuration gave the maximum of the diagrams that you showed? Which was the most high performance?
Element.
Element.
Which was the best?
Which was the
See,
best
these
one?
are all basics. Okay. So the performance depends on how actually you form the vertical. Right now, vertical is by what it is all same this thing. Only elevated vertical is the best for me. I go with elevated because that's what I find maximum easy to tune as well as maximum efficiency. And if you want to go with, if you have a height, some tall tree, I will also go with the dipole. If there are two tall trees, then it becomes slightly directional. If I don't want to get into some one-side radiation. If I want to do switching, I will go with this type of a thing. But this is more complex, I don't have that much energy also to do this. So, can you hear anything? I will switch between the two. You will realize. So I want volume is just is it the best one? So you will hear the difference. Okay, you made up. I just wanted to show you the difference, what it makes on the other side. On our side, when we measure the FWR, that's game over, right? FWR is okay, and we will run into the and do some party. But the other side, how they feel, it is not. Yeah. We will make a difference. Now everybody is talking in this. Can you? This you will be hearing, right? But there was a audio prior to this. Did you hear that or no?
Yeah.
Okay. Now you see this. Yeah. This is the difference. First time when you hear, what do you hear? You hear a whisper. That is what actually most of the people sound when they put the antenna. Not nearby at a DX space. Second one, same antenna, nothing changed, only location and elevation. That elevated radial and location. Same antenna, no other configuration change. So that is why it is very important that if you go back also, you will see the same gap. See, this is the 12 difference, 2 S units. What you hear now is the 2 S unit difference. And we say LAS unit. But that is what actually makes a big difference when you actually have a noise in the background. And that is not a big effort. Only thing is, okay, if you even eliminate that particular thing, it is at the sea level, but even if it is not sea level, and if it is elevated, I will show you one elevated antenna. Just elevate the radials. You will not be like plus 3.87. It will be like 2 degrees less than this, but it will be much better. It will be like I had that also shown somewhere else earlier. What is the strength? That much difference it would be. So the reason why I brought this audio was this is actual recording of me from Caribbean. Okay, when one of the contestants was on the other side, he was recording all the things. He has K530 his call sign. He actually puts every year, he puts the recordings on the website. There is an archive. I can search my call sign and go to that archive and see how he recorded, how he heard me. By the way, this is not my vertical, okay? What he heard. Not the same thing, but I am saying I just made up that to show you the difference between how it will sound differently. And thank you. And we will show you this particular antenna now. This is the elevated radial. Last time I brought in October, I think some of you will remember, I made some changes to that with respect to some clamping and all. Just if somebody is interested to see how it is and how to make it, please join me. Otherwise, I am done with the session. Any other questions?
This measurement is specially done or only for the telescopic advantage?
Yeah, this particular thing is already available.
I have it. So nothing to do with nothing to do with
full
lens.
Yeah, so this is up to here is a 20-meter band,
Okay.
up to the coil, and after coil there is this is a 20-meter band. So you will see some this much length added for 20 meter. And after that small coil is there, top loaded, and one small element.
For what?
What?
Guys, we have seen the vertical antenna and elevated system inside our theory session. So basically, to prove that it works, so we have built this antenna, vertical fan antenna with for 4 bands basically. It is using already readily available fiberglass and aluminum pole. The base is built with that. Up to here it is a fiberglass, and above that is a standard dhoti, aluminum dhoti with some extension at the top. Top has got a small top loading coil for 40 meters, and below that coil it is a 20 meter resonating section, and above that around 70 centimeter is a aluminum section for 40 meters, and there are 2 spreaded radiator wires on the both sides. We can put another 2 radiating elements. This is one for 10 meter and second one is for 15 meters. So basically it is, this antenna system has got around 4 bands at the moment, and we just tuned that with the good results. We just have to tune further so that the resonance comes to the band segments. Here you can see common mode choke with the small arrangement here to take the radiating wires up and the radials down. The radial system is called a vertical open ring system. This is basically elevated system of resonant radials with 40 meter on the outer side, and 40 meter, 20 meter, 15 meter and 10 meters. And what happens here is since it is a single radial system, the tuning becomes very critical, and it has to be elevated 4 to 5 feet above the ground level. We just made a temporary arrangement to keep it inside a plastic drum so that it will not fall off, and it has to be circles in the mode of circle around the base of the antenna. And the tuning wise, once the radials are cut to the measurement, these radials are cut to the measurements and radiating element is cut to the measurement, you just have to measure the SWR and play with more with the radials than the actual vertical radiators. It actually performs much better than anything available in standard market for the ground mounted system, because it is most efficient, and this antenna is popularized by famous N6BT, Tom Schiller, founder of Force 12 antennas. So this otherwise this is nothing but fan vertical systems, and one center element is just with the loaded coil and 40 meters. So that is the system which can be put on the field in 10 to 15 minutes once it is all tuned and quickly assembled to go on air.